because we'll wait for him. Let me see if I can check with him if he's joining.
President sir has joined already.
Sir has joined. Oh, great.
Yes, he has joined.
Oh,
He's already there.
Oh, he's already there. That's great. So
yes.
अंडा जी नमस्कार.
नमस्कार.
मैं आपके पहले ज्वाइन हुआ था अंडा साहब.
Oh, अच्छा सर, मान लिया सर.
Yeah, आपके पहले ज्वाइन हुआ.
Okay. Agreed, sir. Agreed.
नमस्कार सर ठाकरे जी. नमस्कार.
नमस्कार.
Welcome sir. Welcome.
Thank you very much, sir. Thank you very much.
नमस्कार.
A warm welcome to our president of IEI, Dr. Hemant Thakre ji, and he's really taken our personal invite and taken out time from his busy schedule. So we'll just give another 120 seconds, and then we'll start the proceedings, sir. Is our Nagraj sir there, or G. Ranganathan sir?
No, I think only President sir is there. Even
Okay.
G. Ranganathan sir is also not there.
Nagaraj will not there. He's traveling at this time from Shiknu to New Jersey.
Okay.
He will not-
Okay. Fine. Okay.
And Chairman Kate is also not joining, sir. Is it?
I requested him that he was busy in the meeting. He told me that I asked him, you can come at any time in the meeting also.
Okay. Then what we'll do is, with permission from President, we'll start.
Okay. So I'm starting it right now. Very good
Sir, we
evening.
can start. Yeah.
Thank you, sir.
Very good evening and a warm welcome to all of you on this wonderful day. I thank Institution of Engineers India, Faridabad Local Center for giving me this opportunity to moderate this webinar, special webinar titled Optimization of Natural Resources and Design Towards Sustainable Construction. I, on behalf of IEI Faridabad Local Center, heartily welcome all the attendees and thank you for taking up time from your busy schedules and gracing this webinar with your kind presence. This webinar shall be available on our Facebook page and also on our YouTube channel and can be referred back at the later stage as well. To start the proceedings now, I now invite our chairman, sir, Shri Sandeep Narang, to kindly deliver the welcome address and set the ball rolling for the webinar. Sir, please.
Thank you, Engineer Deep. It's my privilege and honor as chairman to invite one and all for this powerful pack webinar. I first would like to thank from bottom of my heart our president, Dr. Hemant Thakre ji, for taking out time and giving us an opportunity to wisdom and ideas on the topic. To start with, we had two more our senior members from Engineer Nagraj ji and Dr. G. Ranganath. I believe both of them couldn't make it out because they had prior commitments and they were busy. So now to start with, we have four very able speakers today who would be taking us through the topic. The speakers would be three gentlemen and one lady. The gentlemen are Engineer Panki and the lady would be the architect Upali. So this mix would take us in details about how do we go. Talk a little about the topic, optimization of natural resources and design So if you really see it out, in today's topic, it takes everything. It takes design as one of the major inputs to any engineering or engineering chapter, and the natural resources where the engineers work on and deliver the goods. Now, out of this, what we talk about this, but with this, there's a superlative word called sustainable. What sustainable? Sustainable construction. So today, it will be very specific and limited to what civil engineers and architects build the infra and give the 0, 0, 0. When we talk about zero, we talk about zero net in energy, in water, in resources, and other things. All of us have got the first effect of the pollution and the effect the natural resources we are basically damaging by the temperature rise, which directly goes to carbon. Anyway, our esteemed speakers will take you through this. I would add only two things in this. The sustainability, when we talk about it, it is what we have to at a certain level or we have to make at a certain rate. Sustainable is always relative. So when we talk about sustainable, today when we talk about sustainable, we talk about whatever has been derogated, degraded, we cannot get it back. But whatever, wherever we are today, we have to sustain this, not let it go worse on any of the fronts from here. Now, there are three dimensions to any of the topics, what we talk about it. There are three, what we talk about is anything will affect as a sustainable for a societal goal, which conforms of three things. Societal goal takes three things into it. This is environment, economics, and social. So these three things are directly, indirectly affecting the sustainability. And to cover all this, what we see is all these three concepts go into three different dimensions. What are the dimensions? One is the global dimension. The second is the national dimension. And third, what is the most important all of us as is the individual level. So I think today our able speakers would be taking us through all these three dimensions and all the three concepts across and help us out, guide us out, how well at an individual level also can we contribute in this. Thank you. And once again, welcome to one and all. And we look forward for an effective participation from all the present guests here. Thank you. Back to you, Indradeep ji.
Thank you, sir. Thank you for your thought-provoking statements. And really, sustainability is the need of the hour. And I think this forum, IEI, is the right forum in which we can address this burning problem of today. With this, I would just request and our Honorable President, sir, Dr. H.O. Thackeray-ji, to kindly address our attendees and our panelists also and give us a thought towards this, the theme of the topic. Sir, please.
Thank you, Indradeep ji. Eminent panelists, Mr. Sandeep Narang, Senior Consultant, Sustainable Construction, Mr. Subrato Rath, Joint Director, Associate, Mr. Pinaki Dasgupta, Joint Director, Associate, Architect Rupali Gadakkar, Sustainable Designer, Mr. Sandeep Handa, Chairman, Faridabad Local Center, Mr. Kuldeep Rajgupta, Honorary Secretary, Faridabad Local Center, Moderator, Engineer Inderdeep Singh Oberoi, Director, AD Global Synergies Private Limited, my council colleagues, members of Civil Engineering Division Board, committee members of Faridabad Local Center, IES staff, and dear participants. I considered it a great opportunity for all of us to be a part of this webinar on a very contemporary topic, optimization of natural resources and design towards sustainable construction, being organized today by IEI Faridabad Local Center with renowned speakers from the field. The Institution of Engineers India, the largest multidisciplinary professional body of engineers, has always been in the forefront providing valuable inputs to the government for making policy decisions, especially on the issues related to social development, disaster mitigation, and addressing to the global crisis through engineering solutions. Today's theme, selected by the Faridabad Local Center, is applicable globally and is relevant for the society. Development of a nation is associated with construction. Construction and building projects continues to be major contributor to the economic growth as well as environmental degradation. Construction and building projects consume natural resources, including land, water, and power. Also, waste resulting from the process results in environmental pollution. Sustainable development can be ensured by sustainable construction, which is a step towards green and eco-friendly construction practices to solve global environmental problems. By optimizing the use of construction materials, the environmental impact of construction projects can be minimized, resulting in sustainable construction. I hope today's webinar will enlighten us about the various aspects of sustainable development practices, as we have with us renowned speakers from the profession. I hope the knowledge sharing session will be a fruitful and interactive one. I wish this program all success. Once again, thanking you all. Namaskar.
Thank you.
Thank you, Urmat sir. Thank you. Thank you for your statements and your kind words for the work done by Faridabad Local Center, and we highly acknowledge and thank you for your kind words. Moving ahead now, I would now like to set the ball rolling for the webinar. I would now share my screen and give you a basic input as to what we are talking about and how we should start working on it. I think my screen is visible now.
Yes, sir. Go ahead. Go ahead.
Yeah. So, starting it, the main objective of this webinar today is the need for us to create our bonds with our Mother Earth. For centuries, we humans have proved that we can live in a sustainable manner. But this modern fashion which we've imbibed in the 20th century, this harmonious link between nature and man is broken. And now in 21st century, it is a high time that we form this link better. The session ahead concerns with a sustainable construction technique, which can be incorporated in our building construction and can help in achieving the sustainable development targets. The topic basically encompasses of two things, natural resources and design. So both the aspects will be deliberated by our panelists in the forthcoming session now. Talking of IEI, most has been referred back by our president, sir, but I would like to mention that we are more than 100 years old organization, and we have a glorious years of working for national building. We have always been in the forefront of dissemination of knowledge and information related to all the facets of engineering disciplines. And our vision has been the growth of technical knowledge and capacity building toward the cause of sustainable development. Now, that's the key word which we have in this. And I'm proud that we have been successful in working on this vision. Talking of sustainability, we need to know that it is that form of development that meets the need of the present without compromising the ability of the future generation to meet their own needs. In other words, it is basically maintaining balance in improving our lifestyles and preserving natural resources. Talking of our own country and the world as whole, we are facing unprecedented financial and environmental challenges in the pursuit of achieving rapid growth. Now, this business model of growing at any cost, which we have taken up for last so many years, it has resulted in deterioration of economic activity, security of the environment. And we've seen what last 2 years have been to our planet, what we have gone through as regard of COVID is concerned. And the reason of this deterioration to our mind is that more emphasis is being given on the active design strategies. We are forgetting our vernacular architecture, our vernacular design systems, we are forgetting that. So important is that we should go to the roots, we should see our design systems, we can go for natural resources and see how we can develop sustainability. There's a silver lining now. Many webinars, many thought processes are being conducted on the word sustainable development. And that is important because until we move towards this new development paradigm, which focuses on economic resilience and improved quality of life and ecological sustainability, it's difficult to get out of this problem. Talking of our building sector, we contribute more than 40% of the world resources in construction. Talking of the IPCC Intergovernmental Panel of Climate Change, they show that this carbon dioxide emission is going to go 1/3 in 2030, and that's really an alarming situation. This is our quote from Ved, Mata Bhumi Putro Aham Prithviya, which means essentially, Earth is my mother and I am her son. This is our Indian culture. We respect Earth as our mother. And this is the reflection of the deep understanding and respect that we have for our nature. Talking of our history had provided us with lessons which are invaluable, especially living with the harming of nature. And for thousands of years, if we see all our heritage buildings, advent of technology, people used to adapt to their environment and use nature as a guide to create their shelters. Let us see some of the architectural application. Our Indian architecture has always been innovative, always devised ingenious ways to make life easier without compromising on the natural resources. Let us see some examples. I think we all know this building. Yes, it is Jaipur's famous Hawa Mahal called Palace of Winds. It was designed by architect Lal Chand Ustad. And we can see the exterior of this building. It has 953 intricate small windows. These windows are called jharokhas. Essentially, they were built to screen to shield the women of the royal household from the public view. Now, these jharokhas also let the air currents flow in such a way that the whole structure gets adequate ventilation, thereby air conditioning the entire area. This building, what we are seeing, it's a wind palace of Jhunjhunu, the Khetri Mahal. As the name suggests, this wonderful architecture allows the cool wind currents to blow through the palace. Talking of the structure of the palace, this is the inside structure of the palace. We see that it has been designed without any doors, without any windows. It only uses archways and pillars instead of walls. Now this ensures a continuous flow of cool air. We all know this great building. This is Amer Fort in Jaipur. This fort is a reflection of Rajputana style architecture, and it has been inducted in UNESCO World Heritage List. Talking of this fort, this particular portion is called Sukh Nivas. Now this hall has been built with a channel of cool water flowing through it. And now the water cascade, which works in combination with the cool breeze blowing through the hall, it turns into an air conditioning the whole of the spaces. Even when talking about the use of natural light and ventilation in this fort, it has been made to the fullest extent. Since there was no electricity or fossil fuel, natural lighting and ventilation had to be taken up in priority. And such places like Diwane Khas and even Diwane Aam were designed without walls and had adequate day lighting and ventilation. So after seeing all these examples of architectural marvels and our rich history, it's important to question ourselves. We as urban planners, architects, engineers, professionals need to go back to the drawing board and history books to take a lesson or two on how to design green buildings and create sustainable cities. We need to understand that not all innovations are high-tech. Sustainable design should include many natural and low-cost ways, if possible, like older generation devised methods to use natural resources like air and water. Therefore, modern sustainability call initiatives for integrated and synergistic design for new construction. And the solution for this is switching from regular buildings to high-performance green buildings. And for that, integrated design approach is required, which looks into all possible alternatives related to design and materials. And that is the crux of our webinar. So there is a pressing need for us today to look for construction technologies, designs, materials to produce inherently low energy buildings. I would, not taking ahead much time, I would now call on our next first speaker of the day, Mr. Sandeep Narang. He is a senior consultant. A brief of Mr. Narang is that he has more than 30 years of experience after completing his civil engineering from Delhi College of Engineering. He is a respected and well-known veteran within the infrastructure and construction domain in the country. He consults on projects on prudent use of resources, helps project teams to meet the green and sustainability goals. The projects he consults are related to outdoor air quality and optimization of water usage during construction phase. He is also senior advisor to SHM Gem Building Council, Green Building Council. So I'll just request now, I'll stop my screen share and I will request Mr. Sandeep Narang ji to kindly take over the proceedings and kindly enlighten us with your views. Sir, please.
Good evening, everyone. I hope my screen is visible.
Yes, sir. Your screen is visible, sir. Please.
Visible,
And I'm audible too.
Yes, sir. Yes, sir. Please go ahead.
Good evening, and thank you. Big thank you to Institution of Engineers Faridabad chapter for inviting me for this discussion. Honored to be here. Also, I am also engineer, but I have never been member of Institution of Engineers. I would love to be member of Institution of Engineers. I would love to know from the team members here how to go about it. So I will follow this presentation structure, a small introduction on the works I've been doing. I'll talk a bit on sustainable construction and on construction emissions. That's air quality and construction. So that's one of my topics for today. Then I'll be talking a bit on tackling construction dust emissions, sustainability as a skill, and sustainable engineering processes construction phase. So that will be the flow of my presentation. So I'm a civil engineer and I practiced active construction for first 28 years of my career. So I got interested in green buildings. Then somehow my focus shifted on clean construction. And I've been part of National Clean Air Action Plan. So I'm advisor at advisory role to few municipalities also. And I have done few handbooks also on clean construction. You will see them through my presentation. The National Clean Air Action Plan deals on various contributors to the ambient air quality, like emissions from industries, transportation, even our construction. So these are road dust management and construction debris management, they call it. The way they are contributing to outdoor air quality, and Faridabad and Delhi, we live in through the worst air qualities, outdoor air quality areas in India. So what's the role of civil engineering? That's a thought process over here. Now we have been talking about sustainable construction, and we heard a bit on green buildings also over here. What's happening in this phase of green buildings? See, the design has gone green. During operations, the projects do show efficiency on energy and waste management, water efficiency, or other factors. But what's happening during the 4 to 5 years of the construction? This is one of the gray areas which hasn't been addressed. We are not constructing in a sustainable way. So my works have been on sustainability during construction. Why it's happening? Because of the low wages, low skills and ratings, being unproductive and inefficient. So these are very gray areas, because first 2 years when we design the project, we go for green building certifications. During the operations, we showcase all the efficiency parameters, but during construction, nothing concrete is happening throughout the landscape of India. So this is how the problem is. So my definition for sustainable construction practices is, if I am doing a project and I can showcase no wastages of water happening during the construction phase, or I call it intelligent utilization of water during construction phase. Measurement of energy and water consumed during construction, and what should be the benchline for the energy and the construction. now with the lots of machineries being used at the project site, it's more than 3 to 4% that we spend on energy. Air quality and construction. This is the main topic for the day today. Reuse of construction and demolition waste. Can we create zero wastage projects where the projects don't waste water, don't waste energy during construction or care for air quality? So this is my definition of being sustainable during construction or sustainable construction practices. I start with this slide. As I have told you that I am a professional working in the field of air quality and construction or clean construction. This media news is from the day one of GRAP. GRAP is Graded Response Action Plan. When the air quality goes beyond 400, AQI is beyond 400, they stop the construction or they start thinking in terms of stopping the construction. That has been happening over the last 5-6 years in say 6 to 7 years in the NCR region. So on the first day of GRAP, that was October 7th last year, Honorable Environment Minister of Delhi government, he goes out for a visit to one of the project sites in Pragati Maidan. And he sees that although there is a fogging machine or smog gun over there, but there is no water in that. Tarpaulin net has been put up for show either in parts or was completely torn apart. And he finds that particular project 5 lakh rupees. That's okay. 5 lakh rupees, fine. So what's the big news in it? The big news is that the company constructing that project was L&T. L&T is one of the premier construction companies in India. Now, if L&T is getting fined in Delhi for not being able to showcase restraint on air quality, what's happening to the other? So we will be doing a root cause analysis of this slide as we go through this presentation. And so that's the idea. I will run through my works and I will show you. And at the end, we come back to this slide again and see what could have been done to prevent this fine on behalf of L&T. So what is construction dust or construction emissions as we talk about? It's a residue of construction activity and process. At the project sites, we keep on doing all the activities like earthwork in excavation, we do for dismantling work, plastering work. Whatever processes or activities are happening at the construction project, we are emitting something into the outdoor air. And construction dust is happening 24/7, all 365 days a year when works are on at the project site. These are the few facts. And when I talk to my civil engineering teams, I tell them that we should be tackling construction dust in a similar way. Automobile engineers worked on the vehicle exhaust. So they worked on the processes, on the fuels, and over a time period, the exhaust was cleaner. You can't have zero exhaust. Now EVs have come with the zero exhaust. And what's the mandate? The mandate for clean construction is to mitigate emissions from construction processes, that's primarily particulate matter, PM 2.5, PM 10, within the micro boundaries of the construction process. This is our mandate for clean construction. And going through this pie of Delhi, PM 10, PM 2.5, road dust and construction dust, PM 2.5 and PM 10, these are close to the tune of 50% we are doing. And another information I would like to share is that during summers, PM10 construction, this is study from Terry ARI 2018. During summers, PM10 contribution is 41 to 43%, and PM 2.5, 35 to 38%. And during winter, it's less. But our works get banned. The construction is stopped during the winters. So we should be working on construction emissions throughout the year instead of just thinking about it during the October, November, December. And another interesting topic is the pie of road dust. What we see as a road dust, what's the proportion of construction dust coming into the road dust? So there are no studies, although I am part of a study happening in Surat with the World Resource Institute, where we are doing all these studies, and I'll be able to share as the studies get complete about the results of these studies. Why is construction dust a problem? Because it creates health problems with respiratory health problem with the people who are working at the project. It causes environmental degradation, including air and water pollution. It creates problem with visibility and safety. It damages dirty property and belongings. And it increases the cost associated with the loss of material or even sometimes additional works get involved. How is it caused? It's caused because of the demolition activities, site preparation activities, construction and vehicle movement, uncovered stockpiles. This we all know that these are the things. And benefits, there are immense benefits of going for effective dust control to everyone. To the builder, it enhances their building reputation. To the owners, it reduces the risk of damage to property, to neighbor and communities, and particularly to the environment, because if we can do clean construction, it's reduction in air pollution, even in the water pollution, and disturbances to existing flora, fauna and habits. So these are the benefits of effective control of dust during construction. And what are the constraints to the construction dust or construction emissions? So we primarily see two constraints. One is the soil type. In Delhi, we work with alluvial soil. So this is one of the constraints, because this soil is very loose in nature and it's mostly sandy and clay soils. So when we disturb the soil, we get that PM 2.5 starts hanging into the environment or outdoor air quality, and somehow we see that dusty feel around the projects what we are doing. So whereas this is not happening in the Maharashtra region, I'm also consultant from Maharashtra region or Gujarat region, where we have those black soils and black and gray soils. So this is one of the biggest constraints is the soil type where we work in Delhi or even in Faridabad. And the second constraint is climate. Because we are into this hot and dusty climate zone, so whenever we disturb the soil or whatever happens, the soil tends to hang more into the air. So construction dust is a bigger problem in Delhi or in this in the area we live in. With a view of construction dust, Delhi is in disadvantage for both soil type as well as climate type. And how do we tackle this construction dust? What are the processes? So basically, we need to have the help of three helps we need to take. One is the help of technology and innovative ideas of the project teams, and third part is training and capacity building. This is in our National Building Code, Volume 2, Chapter 11. I have even mentioned the page number, Approach to Sustainability, where National Building NBC talks about restraint on the noise, talks on noise monitoring, water monitoring, and even ambient air quality monitoring. We don't do that at projects at all, although it's already mentioned in National Building Code. Now in Delhi, we have made it compulsory to monitor the air quality. Projects with 20,000 square feet or more they have to put air quality monitors, and somehow this is going strong, and this enforcement will be coming to the other parts also. And these outdoor air quality sensors that have been prescribed by DPCC, I was part of that committee also, framing those 14-point guidelines. They are very economical. They don't tell you to put costly sensors for the research work. This Airveda sensor hardly comes for 20,000 rupees or 30,000 rupees. So at least we know what is the air quality of our project. These are similar project site outdoor air quality monitoring from one of the Ahmedabad company manufacturer. The second is the smog guns. Although I'm not a big fan of smog guns, I will share with you why. Because in Delhi, they have formulated a rule saying that you have to use smog guns 3 hours in the morning and 3 hours in the evening. The construction professionals or the construction team or the project team knows about the processes, whether that day those processes are happening at the site, that will be emanating PM 2.5, PM 10. And if the monitoring, outdoor air quality monitor is showing some emissions happening, then we should be using these smog guns. It shouldn't be a practice. If the work is, even if the work I have seen, even if the work is not happening, they are putting on these smog guns for 6 hours, and it's just waste of energy and water. But they are very useful during demolitions. They have to be used during demolition for settlement of dust. Again, wheel wash at project sites. This helps it not taking out the construction dust out from the project site. So this is also not happening at lots of projects. People just don't want to, don't have, this doesn't happen, although it's not a very costly thing. Now, this is the difference. This is a photograph from Kartarpur Sahib corridor in Punjab. This is how we constructed road, and this is how the roads are being constructed outside India. They are putting the mulch carpet, and this carpet mulch is the same thing that we burn during the winters, and it will be causing again lots of disturbance to the air quality of capital. So this comes from that parali only. We can make these mulch carpets that will be being burnt on in the month of September, October. Hydro seeding, hydro mulching. These are few of the things that we don't use at all, and they're highly inexpensive ideas or ways of controlling emissions from the construction project. We see a lot of open batching plants where they should be closed batching plants. So I've just given you few ideas where the construction dust comes from and what should we be doing to control that construction dust. We have a project schedule at site where we know which activity is happening when, but we don't create. It's a very small effort if the companies can start making a construction dust mitigation schedule where they know they don't get surprises from the pollution control board. Okay, you have to do this for this. You can plan in advance from day one about how to mitigate the construction dust. These are the two handbooks I have been part of. Handbook of Clean Construction Practices in Surat for Surat Municipal Corporation, Advancing Better Air Quality with Clean Construction for DPCC and Clean Air Asia. Another handbook I have done for Maharashtra that will be getting launched next week only. So you can, people can, who are interested, can download these handbooks from the net. They are open source handbooks available for everyone. Now, why is this problem? The problem is that on the left is project teams and the right is the skill levels. We all sitting here, we are from the top management. We are highly skilled people. As we go down, lots of people working at the project site, their skill sets are very low. And we call it, this is a iceberg of ignorance. The problem of wastage of water happening at project is known to 100% people who are very low on the skill set, and it's known very less to the people who are on the top of the ladder. How to counter that? What we do at the project sites for the management, we call it, we go through this loop, observe, orient, decide, act. We call it OODA loop. We do it for the security of a project. We put on signages at the project site saying you have to wear helmets, don't touch wires. But nobody will see any signages for the observation of project staff or anyone on sustainable construction, of not wasting water or not emanating air quality. So this is the way forward for construction companies. I will, in the end, I will show you 5-7 slides how I have been doing at the project. We have to put visuals at side. I call it informative stage. We put visuals at side. We create company policy for air quality during construction, water uses and energy uses. Then we create this, take it to the next level. We call it voluntary stage, where we train staff for sustainable construction practices. Lean construction management is a very wonderful tool because it talks about wastages at construction site. And then comes the assertive stage when you link this with the KRA. Now, this is a project at Jaipur, Trimurti divinity of a real estate developer. So there you can see we have put a small outdoor air quality machine which is measuring the outdoor air quality of that project site. This is from Airveda, costs hardly 25,000-27,000, and there is no compulsion from Rajasthan Pollution Control Board or any regulatories to do this on this developer. There are the signages at project site on awareness and training. This is signage at Signature Global Project in Gurgaon. I am part of this also, doing sustainable construction practices over with here. And this is very interesting. This is air quality monitoring report from Trimurti Divinity, 31st March to 15th April. Because the work is happening at lower basement level, there is nothing happening at the top. There are hardly any deviations in PM 2.5 and PM 10. We are doing monitoring at 12 PM and 6 PM. There are the 2 hours when the project is at, the works are at the topmost stage. And so the builder is very confident. It shows this, my project is not giving any emissions. There are stages there are only few times when a construction project sends emissions into the air quality. It's not happening every time. And we are getting banned, our construction is getting stopped, we are putting as a bad label just because we are not monitoring our air quality. So this is the company policy of Trimurti Group again. And I have to run through because I'll be close to my 20 minutes. I know I have put my stopwatch on. So the presentation can be shared with all the whosoever wants it, and you can go through it. This is company policy for water conservation. And this is how curing of water is happening at many of the project sites. And this is how it's happening at Trimurti. They are using spray guns. There are no water runoffs. And if you don't see mud puddle at a project site, it means that no water wastage has happened. If you go to a project site and see what mud puddle anywhere, it means water has been wasted and that mud puddle has been created. In multi-story construction, if you see water in the basement, it means runoffs have happened at the upper floor during the construction. The idea is to create these zero water wastage projects. We should be having these signages at project site, and intent of the project team should be not to waste water or air quality. This is what I call takeaway from today. Understanding of construction dust generation from processes, constraints from soil type and climate, being innovative for dust mitigation. Nobody can, Europe and US can come and tell to Indian engineers, okay, you have to do this to mitigate the dust mitigation. We have to be innovative and do our own stuff. Measurements of ambient air quality at site, creating policy for dust control at site, training and capacity building of the site. Now I come back to that first slide and do the root cause analysis of why L&T got fined. They had that smog gun, they had those tarpaulin covers, yet they got fined because there was no training and capacity building of the workers at that project site. And I have at one of my programs, the L&T project manager or project head who was manning that site when that project got fined, he met me in at Delhi Secretariat and he said, Sandeep sir, you are absolutely right. We missed on that point. So I will request all the engineers who are attending to do lots. If we can, we have to spend nothing and we can take off 80% of our the construction emissions just by using small processes, as Indradeep Saab also showcased, that being sustainable, and if you have right intent, we can take off 80% of our construction emission. So my request is to be proactive in tackling construction dust. Project should showcase technology support, policy. Project teams should be having knowledge and ideas of how to mitigate construction dust within the construction boundaries. And I sign off with this: in the race of excellence, there are no finish lines, and we civil engineers should be aiming for the race for the excellence. And these are my mobile numbers. I will have, if anybody wants to note down, please come back to me if you have any questions later on. WhatsApp me and set up a time for the call. I'll be always happy to answer. Thank you. Jai Hind.
Thank you, Sandeep ji. Thank you for your valued presentation. And in fact, whatever points you've raised is really, first of all, congratulations to you that you've been able to at least deliver and at least put into the project sites which you are doing, that doing the dust mitigation measures and also the water conservation. It's really good. And I think what the takeaway from your presentation was that the word you mentioned, iceberg of ignorance. Yes, we all keep on talking at the higher level, but what happens is, no, it does not percolate down. It does not percolate to the actual person doing at the site, and that is where the problems occur. I thank you for your adhering to the time also. Thank you very much, sir. And I at this moment, I would just like to put in one word that the attendees have raised their hands. If you could just write your question in the Q&A box, that will be nice, because raising the it will be difficult for us to unmute you and having you on the forum. So I would just request you to put in on the Q&A session, and all your questions will be taken at the last leg when all the presentations are complete. So you can go through the presentation, you can really hear all the participants out, and then we will take your questions. I would now share my screen, and again I would invite our next panelist, Mr. Subhabrat Rath. Now, talking of him, he is also associated with ASSOCHAM as a joint director. He is currently a regional head of Bihar, Chhattisgarh, and Jharkhand division. He did his master's degree in physics in University of Massachusetts, Boston. He is a mechanical engineer and certified green professional. He has a more than decade of experience in India, US, and Middle East, in Asia, in the field of sustainability, teaching, motivation, research, and site implementation. So I would just request him to kindly take on the ball rolling and kindly adhere to the time limit of 20 minutes. And I would request Mr. Rath to kindly take up his presentation, please.
Thank you, sir. Let me share the screen, please. Thank you, Mr. Oberoi. I think you can hear me, right? And this slide is visible.
Yes, yes. Please
Okay.
continue, sir. You're visible, you're audible. Please continue.
Sure. Thank you. So that is an awesome presentation from Sandeep ji, and I could completely relate to it. So good evening, everyone. Myself, Subhabrat Rath. So I'm the joint director of ASSOCHAM, and I also look after Bihar, Jharkhand, Chhattisgarh here. So here we are discussing about several elements, like already stated. We're talking about design, construction, sustainability, and optimization of everything. And we in ASSOCHAM also very much careful towards all these things. So what is happening here is we are talking about constructions, and the constructions, air pollutions that Sandeep ji was already mentioning about. For the designing side, we have Rupali ji with us, and for the assessment tools and certain other perspectives, we have Pinaki ji with us. So I thought of giving something new, something different that would stand for the psychological thing. So what it means, basically, before I start with these presentations, I would like to reiterate certain facts regarding the air pollutions, because I work in certain certain projects in Saudi Arabia and Bihar as well, in Bahrain as well. And the dust pollutions in those kind of places, and it is completely, you cannot imagine, unimaginable. And the kind of things we are doing there for the sustainability is just those kind of along the lines that Sandeep suggested. And when it is an organized sector, it is easier but when it is unorganized sector, it is even much worse. So thank you, Sandeep ji, for taking that point here. So friends, in ASSOCHAM, sustainability, environment, water councils, and everything has been taken very seriously. So I'll start this presentations with this kind of quotations, which basically means is that we are trying to get back to nature. I mean, whenever I talk to someone, also talking to the students here who are here, you can ask me any questions in the Q&A sections. So when you are talking about nature, when you're talking about sustainability in design and building practices, what we are terming is that we are trying to get back to the nature. But the fact is that we are already inside the nature. And so the problem lies in the fact that sometimes we do not know it. We choose to ignore it or unable to recognize it. So the saddest part is that when we fail to reverence any aspect of nature and our intimate connection with it, we are failing to reverence intimate aspects for our own selves. That's the takeaway message of this thing. So why I'm quoting this is that let's talk about one step back. Sustainability, we're talking about design, we're talking about construction, we are talking about a lot of things worldwide, not only in India. Why we're talking about it? I mean, is there anything, what happened recently? Certainly what happened. So are we scared? Are we thinking about the glaciers are melting, that's why we should do it? Or maybe the energy, the fossil fuel divisions, everything, the fossil fuels are not renewable. So we are talking about non-renewable energy, renewable energy sources. And or maybe the the coals are running out of stock, or maybe the groundwater level is zeroing down level, so that we cannot use it anymore. So is it the reason that we are scared of it? And is that the right approach to it? Or is there anything else that can be added here? And when you are talking about the solutions to these things, when you're talking about on-site renewable energy, so what happens is when you're talking about design and construction about a building or nation building also, we're talking about renewable energy, right? We're talking about solar power, wind power, and what else? We're talking about passive design structures. and that Mr. Oberoi just showing that Hawamal and how the intricacies are there. There are lot of examples where there was rainwater harvesting, even in our heritage buildings, right? There is some temple which was using the complete solar rays into it, and these people built it up when there was mostly there is no energy, maybe, right? No energy means the way we look at energy or electricity, right? The electricity was not there. The way we pump it out, all the water sources, that was not existing that time, right? They used to do this hydro turbo kind of power manually or some other ways. I am from a mechanical engineer background, so this is these are the things that fascinates me. Okay, how these people are doing all these things basically, right? There must have been some manual mode. There must have been some kind of things. Even despite all these technologies, the modern technologies was not available. There are certain kind of calculations already existing, right? So we are trying to refer that. Okay, if we get out of everything, maybe this is the thing that we should refer, right? But the fact is that, what is the fact? The fact is that we cannot do this kind of structures anymore because of certain intricacies, because of certain kind of lifestyles that we have. We cannot take it away from everyone. So we cannot take the comfortable lifestyle that we have overnight. We cannot do that. But at the same time, we also have to inculcate this kind of passive design structures, this kind of references into our design and into our construction methods. How we will do that? What is the best way out? And what are we referring basically? So that's why there are a lot of energy codes, energy conservation codes that were recently built. Not recently, but yes, they are right now. If it was existing, right now they're trying to change it. One of the easiest thing, one of the thing that we could relate to was the presentation by Sandeep ji, where there are certain norms, certain kind of practices, certain kind of CSR programs, or certain kind of reports are developed for the air pollutions control, yeah, in L&T and so. There is energy conservation building code, which is talking about how we can conserve the energy when we are building or design something. There are some kind of EPA guidelines, which is talking about how we can conserve water. In ASRE, there are certain codes, there is ASRE 55. And when they started, they made this thermal comfort. Okay, thermal comfort means that is the main thing that we call comfort, or the lifestyle that we are right now going after is basically about thermal comfort. If you take that thermal comfort out, if you take that comfort out, then we can build very easily passive design structures, and there will be no energy issues, there will be no water issues. It will be very easier. I will not say that there will be no issues, but it will be very much easier to design and build all those kind of things. But the main context comes from the psychology of the fact that we want to be comfortable. So there is a thermal comfort guideline for that. And you can see that there are a lot of things made for metabolic rates, for clothing lifestyles, for different kinds of exercising. For example, there is one is going to gymnasium versus I am right now sitting here. So our thermal arrangements are different. My heat load is different from someone is right now running, right? So based on that there are certain kind of psychrometric charts that are developed. Based on which the MEP consultants, the mechanical engineering and plumbing consultants are designing the buildings. And apart from ASRE 55, there is ASRE 90.1, which is talking about energy. And all these things, if you look at the first set of, let's say I am talking about ASRE 90.1 2004 versus the latest editions, it is very difficult, very different. I mean, a lot of things have changed, right? The references are also changing day by day. There are a lot of government, organizational, or private companies are also coming up here, so that these things become more and more stringent, more and more suitable for a better sustainable design and construction. That is the engineering aspect of it. So the point here that I want to raise is that does it end here? Does it end here means, let's say everything, all the people get some kind of bylaws, that the bylaws say that okay, do it. Let's say they accept it. And let's say that all the references guides that we are talking about, ECBC, ASRE, or whatever, everything is in line. The triple bottom line of social, economy, and environment is changed. Profit, planet, and people, we call 3 P's of life. Everything is set. Let's say in the next 5 years we set everything. Does it end there? Our responsibility ends there? Because what might happen is the students who are listening to it, they might think that okay, everything sab kuch to aa gaya, everything is in the bylaws, we have to do it. So what is the issues there? why we're so much concerned about it, why there are so many people talking about it day and night, about design, about optimization, about natural resources conservation, because everything is right now in the correct step. See, the thing is that it does not end there. Okay, the reason is, even if you do something good right now, unless and until you make it a lifestyle, unless and until we make it our lifestyle, it will take 1 to 2 to 3 generations to do that. If that practice does not become a normal, then again it will come back to the whatever right now we are doing, and all these bad things will again shoot up. So we cannot stop here. We cannot just say that okay, everything is set. We just our plan is not to make these things only in the bylaws or a part of the some kind of reference guides or some codes or something like that. Our planning is also to rechange or relook the definitions of nature that is inbuilt within us. Right now, the definition of nature. Let's take a step back. What is nature for us right now? When we're talking about natural resources, we should first think that what is the definition of nature inbuilt in our mind from the very childhood till now. Then definition of nature is something like this. When we're talking about tourism, when we're talking about tourist places, we are not talking about going to any kind of building. We're talking about like this, some sea beaches, some mountain rocks, or some kind of scenery areas, right? That is our definition of nature. And when go to one step after that, right now when we are going to any kind of tourist places, we are trying to be accommodated in certain kind of places which we call eco resorts. Inside that resorts also, when you go there, there are air conditioning system. It's not purely eco resort, you can say. It's not purely a passive design structure. There is a lot of things which is energy consuming or water consuming, right? Or this kind of things that we are building up right now as a part of our tourism package or something. And when you're going to the industries, we are talking about how we are trading, how we are talking about natural resources, and we're talking about carbon trading, where for every equivalent carbon dioxide produced in some places, we have fixed a price that can be put up somewhere else to be paid there, and we are putting some kind of on-site renewable energy centers there, and we are getting some kind of credit, and now it becomes a kind of business model. So my point here is that when we are talking about natural resources, optimization of the natural resources in both in design and construction, it has to be the definition has to be set properly. The first thing that is for sure is that it's not only about putting it in the bylaws, it's not only about putting it in the in some kind of reference codes and everything, right? That is the first step. Yes, that is a major step. But the other step is also putting it into the consciousness, putting it in the definitions of ourselves, everyone, right? Then only everyone will do that. For example, a few years before or few decades before, there was some campaign like health campaigns for polio or some kind of other diseases. Those diseases are right now not existing because it took like 2 to 3 generations to take that thing away. That is how we are also planning to make that sustainability initiative right now, and it's upon us. So here I will give you an engineering case study. Engineering case study, you can see this kind of ions here, and what is it is not does not look very engineering, right? Because when I was in Boston, and I had this chance of working with some professors who were also working with bioengineering and everything, right? So as a mechanical engineer, I was very much interested to work with some of the research guys. So the professor, there was a Moon Kim from South Korea, Professor Moon Kim, and he was a mechanical engineer as well. So what I am trying to find is that when I'm talking about nature, nature is not just sitting out there. Nature is also inside us. The engineering is not only about making a building. The engineering is also about inside us. This model, what this model suggests is there is something called I'll try to take something away, which we might not sound like a building to you, but I'll correlate that in few minutes. Okay, so there are certain ions inside our body which is called amino acids, right? These amino acids and DNAs are somehow interrelated, and the problem is that there are only so many these nitrogen, and there is hydrogen, there is carbon, there is oxygen. And there are few 4 or 5 kind of molecules are there which can make this 20 kind of amino acids. But the problem is that with this kind of structures also, there is no proper idea that how much kind of variations they can have, how they can move, how they can twist. So this person, this Professor Moon Kim and his colleagues, and I was also in that lab. So we are trying to build up certain kind of structure where we said that, okay, let's use our mechanical engineering brain. So we said that, okay, there is an ion, there are two components, there are so many components. So there can be a molecular energy, there can be a torque applied on that, there can be a spring balance in it. It works like a spring. It also works like a magnetic energy can be there. There is a kinetic energy aspect with it. There is a thermal energy because it is moving inside our blood and everything. So everything you can see, the same thing that we are talking about when making a building, we're talking about the thermal energy, right? U values, the K factors, the glazing factors, the fenestrations, the kind of way we make our design buildings. Okay, it's the same way that is also happening inside our physical bodies. So it is not that the nature is only sitting outside, it is also inside us. It is in our physicality, it is in the building and everything. It is just taking a different forms. Energy can either be created or destroyed. It can only take from one form to another, and that is what is happening around. So let's feel that all of these things, the nature, the building itself, a part of nature. We are nature, building is nature, and everything that we are dealing with, we are not dealing with only with trees and plants and all those things. We are dealing with the entire life process. So that kind of psychological balance should be inside our mind. Then only we can do something. This is for an example. This building is a kind of green building, you can say, where the contour, the slope and everything was maintained here. You can see there is a breeze. And when these people develop it here, they could have completely taken out the water bodies and put it something else, but they did not do it. There you see the water is flowing. They let it flow. The contour are not touched. The way this building is done, you can see the trees were preserved. The trees, whatever was there, it is preserved. And because of this, it doesn't look bad, does it? I mean, sometimes we feel that in the way of making some kind of modern structure, we think that if we take it out everything and make it with concrete jungles, it looks good. No, that doesn't look good. This looks good as well. So if you talk about aesthetic point of view, also sustainable building design and constructions is the way out. It's not only about saving life and how to do that. One of these examples are there that Sandeep was right now mentioning about the soil erosion control. There are a lot of strategies that cannot be undermined, that has to be there. It is in the NBCs, but we are not following it properly. But if you follow it properly, a lot of other things can happen. For example, if you preserve the topsoil, that topsoil can in the future can yield us so many vegetation, so many things around us. If not inside the campus, somewhere else also we can put it there. Okay. And right now we have all the technologies available. We have solar power diagrams available. We have Windows diagrams available, right? And when all these things are available, with all the resources are available, it is becoming very much easier for us to build something rather than for example, in the passive design structure in the heritage buildings. We cannot underestimate the fact that these people built it some centuries before, when they didn't have any kind of software modeling assessment tools available with them. But right now we have everything with us. We can make daylighting modeling very fast. In one day, people can simulate daylight simulations, how things will work if we put a kind of glass versus some kind of wall or some kind of roof or some kind of other kind of skylights and everything, right? There are a lot of permutation combinations that can be tested only without doing anything, without any costing, that's sitting it in our lab. So why not to do it? It's not the sustainability. Doing sustainability is not right now very much costly. It's actually right now it's easy, and it should be the way forward. And this you can see when we are trying to make something very cooler. Cooler means there are two skyscrapers, let's say, and there is a kind of road in between. Lot of places, what we used to do, our standard practices were that we used to make some kind of concrete roads inside, so that the heat what is coming there, it get trapped there, and sometimes it could not escape outside. If you go to Gurgaon, you can understand that those kind of things in many places. Why only Gurgaon? Even in Ahmedabad, I have seen places where there was skyscrapers and there are so many glass facades there, and there is a road, and those heat could not come out, and literally in the summer season the concrete and all these things, they melt. The kind of the upper layer, it kinds of melts there. which is not good for us, which is not good for human lives, which is not good in any way. So there we can have certain kind of strategies. It just needs a sensitivity. Costing does not make many sense here, right? Sometimes we think that sustainability things are costly. It's not like that. If you make a paper block like that or some kind of other arrangement there, all our architect Rupaliji is there, so you can explain you like how can it can be done. A lot of things can be done. The rainwater harvesting, drip irrigation system, dual facets, and this water cycle, we can use the same water cycle, not only conserve it but also recycle it, reuse it in many ways. Even in our landscapes we can use it, in our plus basins we can use it, and it is very much pretty easily available. All those designs, all the strategies, and all the related facets and fixtures are available in the market, not in a very expensive price. So, and also talking about this organic waste conversion and any kind of waste management, not only in construction, also during the occupancy, there are measures. There are things that there is also EUS treatment is EUS converter is also available. There is an organic food waste which is right now people are converting into energy as well. So many options are right now available. So why to be bothered about anything else rather than learning the art of it? We can do a lot of, you see, fire bricks we can use anywhere wherever applicable. We can do a lot of things with the bamboo sticks, because instead of using any kind of hardwood, we can use bamboo, right? Why? Because bamboo is very fastly growing plant. A bamboo plant can grow very fast. If you take one bamboo plant out, it will come out faster than any kind of bigger plants like banana trees or anything. So why not to use it? So coming to the energy design proportion, so this kind of things should be in our mind. This all things somehow relate to our nature, and all these things are in the building level. The design, then the efficiency of the equipments, then the efficiency of the operations plants. The next step will be the energy and behavior education. This is where we need to lay a lot of emphasis, because we have energy designers right now available in our nation. We have efficient systems are available. We have bees working all the way to make it possible. Where operating plants are also available. And this side also you can see ongoing commissioning of buildings. There are energy commissioning, water commissioning. People are really, the professionals are also built up. System optimizations, renewable energy solutions. Government of India is making a lot of emphasis. That's why I chose this topic called psychology, because energy and behavior education, this is what we need to have a lot of emphasis if we want to have a optimization of natural resources in design and construction of buildings. So then only we can truly go towards the net zero buildings. Maybe if you can talk about energy, you can talk about water, you can talk about any natural resources, even air pollution, combating air pollution and all. So this is the gist of it. The gist is that when we're talking about psychology, the psychology, what is going on in your mind when designing something or when constructing something, there are a lot of informed suggestions, informed decisions, and it is readily available, it is readily doable. We have a lot of things to refer back in our heritage buildings as well, and put it in the current context, because those heritage buildings might have been there in the past, but the past does not exist. What we can do right now is we have to alter it a little bit. So the first one, I should say that gimmick versus mimic. So but just by looking at those two structures, you can understand what are the differences. The first one, I am not saying it is wrong. No, it's not wrong. The brand management, brand imaging is fine, but we cannot have completely facades throughout, right? We cannot have some completely, glazing throughout the building just to make it like a gimmick, or some kind of other factor or other things just to attract customers. No, at the same time, there has to be a sensitivity to make it unique and make it mingle with the nature. You can see in the lower half of the picture that there is a mountain with so much trees, and there is also a building with so much trees, and the people inside it, they must have been very much sensitive, so that's why they're living here, right? So these kind of structures we need to adapt, we need to have in mind when building, designing something and constructing something. So now what things are helping for that? The COP is there. The worldwide COP is, we have COP 26, 27 is coming up. Everybody also knows about. Everybody is people are aware of this kind of things. The governments are aware of these things. There are sustainability development goals. I was just saying we are just having a discussion. All the 17 goals are there. Even talking about one thing is very much, it's a one lifetime goal. And when you're talking about the 17 sustainable goals, the sustainability field, you can see so much diversified. This is where the United Nations, we are talking only in the context of building sustainability. So here we are talking about the materials, talking about how to utilize energy or water or air pollutions or so and so. So there are few sectors that are allowed here. So that's why we have also parameters. For example, our green building rating parameters are setting for that purpose. So, and giving a kind of background into the UN SDGs, these green building parameters or end of sustainability building parameters, they have and direct connections with these UN SDG goals as well. For example, with this number 9, building resilient infrastructures, promote inclusive and sustainability industrialization and innovations, that is related to some kind of fire and life safety, passive design structures, construction management best practices that Sandeep Narang was just talking about. Preservation or plants trees on site. So you see, you do one thing and you automatically get linked to UN SDGs, COPs, government plans, CSR programs of things, and all these things are right now interrelated. The just one thing that we are missing here is that awareness, that consciousness that okay, we need to do it and we need to do it for a long term. So that's the way it is right now. I'll not take much time. These are just a glimpses of how everything is interrelated, how everything is interconnected. If we do one thing, it's not just that we are not getting noticed. No, we are giving our contributions to a measure of things in both design, construction, profit, planet, people, economy, and the national determined contributions. We call it NDCs, which are in national goals set up by United Nations. So that's why we also have kind of MOUs, SHM, coming back to the SHM, what we are doing. To achieve this, we have made one kind of MOUs with leading agencies and universities as well to go into the conscious level of students. And we are also doing some kind of waste audits and all these things as well. So that all these things can be taken care of holistically in the design and building industry. So here is my number and my email ID. You can just refer here, and if you have any kind of doubt, any kind of questions on queries, please let me know. Thank you.
Thank you, Mr. Rath, for your intriguing presentation and deliberation. In fact, summing up, what you mentioned is that you've taken a different perspective altogether of how to perceive the sustainability as such. And it's very right that old habits die hard. It's very difficult to change old habits, but it'll take some time. We have to include in our lifestyle and see how we can actually go towards the goal of sustainability. One thing which I really wanted to understand was that you rightly said the concrete paving and everything, because urban heat island effect is a main problem today for our urban areas. And I think the designers should come up with new innovative techniques wherein this UHI effect should be reduced. At the same time, we should have the water percolating to our groundwater so that we should have good groundwater levels. So I think I would just request all our participants, also attendees also, if you have any questions, kindly put on Q&A box. We'll have a session. We can have those questions with the panelists. And now I would go to our next panelist. I now invite, yes, so we have Ms. Rupali Gadkar ji with us. She's a sustainable designer, well AP architect, certified sustainability leader, and social impact advocate. She has done her MS Sustainable Design from Thomas Jefferson University, USA. And she has got many honors and awards. She is a guest critic for Thomas Jefferson University, Burkan Family Scholarship. She has got Nexus Maximus 2018 Philadelphia. She's got a professional experience and she is a sustainable designer now in Pune. And she's designing a K-12 school in a village near Satara. That's a very wonderful your portfolio which we have. And I would just request you to kindly give us some good inputs towards sustainability, and it will be an honor to listen to you. So I would just now request ma'am to kindly take up the proceedings.
Thank you. Thank you very much for that introduction. And I would like to congratulate Mr. Shubha Brata for that wonderful presentation. And very rightly, he spoke about, the nature and integrating sustainability into our lifestyle. And I think we have to remind people about it because we've forgotten that we are part of nature, really. And it's now us versus nature is what is going on right now. And yeah, that's affecting our health as well as planet's health as well. So yeah, I think congratulations, that was a wonderful presentation. Now I'll share the screen. Are you able to see the screen?
Ma'am, please. We are able to see it. Please
Yes.
go ahead. Yeah.
Okay, so first of all, thank you very much for to the organizers for inviting me here to talk about optimization of natural resources and design towards sustainable construction. During this presentation, I'm going to take you through healthy building example, need of sustainable construction, its definition, its framework, and a case study. One building off by itself has zero impact on the world's climate, but a building that is influential and begins to change the way that architects, engineers, contractors, developers, and financial institutions shape the built environment. That's a building that was worth building, says Dennis Hayes from Bullet Foundation. And I completely agree with that. And I'm going to take you through a case study of Bullet Foundation in a while. This is one of the healthiest workplace environments in the world. It's called the Spine, located in Liverpool, and is a home for Royal College of Physicians for over 200 people. Activity in sustainable construction continues to increase, some of it making the continued evolution of thinking about how best to achieve high standards of efficiency in the built environment, while at the same time promoting human health and protecting ecological systems. More than any other human endeavor, the built environment has direct, complex, and long-lasting impacts on the biosphere. And as we all know, construction sector is one of the major emitters of greenhouse gases. After the first significant efforts to apply sustainability paradigm to the built environment, in the early 1990s, the resulting sustainable construction movement has gained significant strength and momentum. Increased CO2 emissions, climate change, pollution, depletion of finite non-renewable resources, population increase and increased consumption, need for creating resilient built environment are one of the main drivers of this movement. So what is sustainable construction? According to Rainsford, it's all about ensuring a better quality of life for everyone now and for generations to come through social progress, which recognizes the needs of everyone and maintenance of high and stable levels of economic growth and employment, while protecting and, if possible, enhancing the environment and using natural resources prudently. So thus the term sustainable construction most comprehensively addresses the ecological, social, and economic issues of a building in the context of its community. So this always integrates, as I've explained in the earlier slide, different dimensions of social, economic, and environmental aspects. Some examples of social dimensions are protecting and promoting human health, social inclusion, satisfaction. Some aspects of economic dimensions are using life cycle costing, productivity, support of local economies, profitability. And some examples of environment are conserve natural resources, creating a healthy, non-toxic environment, waste minimization, and management. There are about 60 different assessment methods for sustainable construction or green construction. And in India, we generally use GRIHA, EDGE, or LEED certification. So now let's look at different natural resources we need to consider. That's land, materials, water, energy, ecosystems. And principles of sustainable construction are reduce, reuse, recycle, protect nature, eliminate toxins, life cycle costing, and quality. And we have to consider this during all phases of construction and post-construction too. But for the sake of this presentation, I'm going to focus on planning, development, and design phase. So this is an integrative building design, and at its heart, a collaborative multidiscipline design process. And contribution from all stakeholders is very essential. We have to learn from the past, as we saw in the earlier presentations. Learn from the past, think holistically in the present, and consider the future. And also, we have to think across scales, that is, think global and act local is a wonderful axiom for designers. It urges the consideration of global effects on each design decisions. Approach to a sustainable construction are vernacular vision, that is, because it embeds cultural wisdom and an intimate knowledge of place in the built environment. High technology approach and biomimetic model. Well, this biomimetic revolution is now considered to be a major guideline towards more sustainable built environments, meaning that the building refers to the technical translation and realization of functional strategies used by the organic systems in nature. For example, this building by Norman Foster in London, the hexagonal skin was inspired by the Venus flower basket sponge. This special sponge sits in underwater environment with strong water currents. Its lattice-like exoskeleton and round shape help disperse those underwater stresses, and both of which were applied to Foster's design to this tower. I'm now going to look at one case study and how we can optimize the natural resources. So this is a Bullitt Center in Seattle, USA. Greenest commercial buildings completed in 2012. It's a 6-story, 50,000 square foot office area, and it has pursued guidelines outlined by the Living Building Challenge. It's the most rigorous green building certification program. I have chosen this case study as all information is well documented and available to everyone in various ways. The Bullitt Center had a single goal to demonstrate the current state of art in sustainable design in order to influence development and operation of other buildings around the world. So this is the energy consumption chart. So average office building, let's say, consumes around 72 kBTU annually energy, and this building consumes only 16 kBTU, and that too is supplied by the solar panels installed on site. And I'll explain in the next few slides how they've managed to get it down so drastically. So talking about natural resources, land and site ecology. Pre-development and old growth and site surveys, historic site surveys, is very important. And that's how this adjacent 104-year-old park is now linked to the center. And actions to revitalize this neglected urban space include native planting, materials reuse, and development as a new urban gathering space. And this wouldn't have been possible unless there were historic surveys and information, vernacular information gathered. Microclimate is thoroughly studied because then building orientation is based on that, like so sun path, wind directions, waterways, native landscape, etc. To utilize natural resources such as solar and water optimally, historic and current data is studied. For example, you can see all these charts. And then, using this understanding of climate, building design strategy is derived. And that helps in achieving thermal comfort, as we saw in the earlier presentation. Thermal comfort is, you can see one chart here, is one of the indoor environment factors that affect health and human performance. This design is based on local climate with the aim of ensuring thermal comfort using environmental resources, and that's called a bioclimatic design. Now, looking at air and light, you can see this airflow here. Operable windows, operable is the term for openable windows as well. Operable windows move straight out to maximize ventilation, but only when exterior conditions are suitable for natural ventilation or night flush cooling. Night flush cooling is another passive cooling strategy, and manual overrides are possible. Otherwise, everything works automatically. So last summer, I think it was quite hot for Seattle, but the building was able to maintain a maximum indoor temperature of 25 degrees Celsius when outside it was 32. Now looking at light, window heads that extend to the ceiling maximum daylight penetration. So 14 feet high windows they have been designed. And this is a daylight analysis. Different colors show different intensity of daylight, but as you can see, maximum floor plate gets daylight, and that's how 82% of the daylight hours, artificial lights are switched off. So they don't really need artificial lights in the entire floor area. And even on the sunny days, fully automated exterior shades take control, so to avoid any excessive glare. And that's how the interiors, as you can see, are they receive a lot of daylight, and the large windows give ventilation as well as connection to the outside views, and that's what brings or gets there. The design improves health and well-being of the occupants. Now talking about water, it's a net zero building. And net zero water building is designed to minimize total water consumption, maximize alternative water sources, minimize wastewater discharge from the building, and return water to the original water source. So they have managed 100% of the water used in the center comes from captured rainwater, as you can see here. Grey water is treated and reused in the vacuum flush toilet system. Excess grey water is returned to the soil to help recharge the aquifers. Human waste from foam flush toilets and urinals arrives through these pipes to the basement, and it's made then compost is made out of that, and then it's used for soil amendments. And this center is designed to help restore the ecological processes of site back to the way they functioned hundreds of years ago when it was a forest. And like a forest, bullet center must use only water it can collect on site, and they have achieved that. As you can see the numbers, if you mimic the forest conditions, these are the water levels, and this is what they've achieved even after construction. Then talking about energy, net zero energy. Net zero meaning the total amount of energy used by the building on an annual basis is equal to the amount of renewable energy created on site. And as we all know, the goal is that the building contributes less overall greenhouse gas to the atmosphere during operations. And they've got the energy requirements down in various ways, and so the 575 solar panels take care of that entire energy requirement. So looking at a path to net zero energy, for example, a typical office building of the same size, if it consumes around 92 kBTU annually. So they've managed to bring it down to 42 by using high performance glass, high performance walls, low infiltration, ground source heat pumps, radiant slab cooling, operable windows, operable blinds. And after this, they've managed to bring it down to 32 by, as we saw, maximizing daylighting, daylight dimming, light changes in lighting power. And then the way occupants are using the facility had got it down to 16, that is maximum use of stairs, low heating set points, raised cooling set points, daylight office cleaning, and low flow fixtures, etc. And that's how 100% of power comes from the rooftop solar arrays on annual basis, and they do not require any energy on the grid, and that makes them net zero energy building. Other sustainability aspect is that ability of the building to maintain critical life support conditions, as in if services such as power, heating, fuel, or water are lost for an extended period, the building should be able to survive. So this building is resilient, diverse, locally attuned, and able to leverage interdependencies and allow for change over time. So the structure is designed to last for 250 years, heavy timber and concrete and steel, and the outer skin for 50 years because the systems keep on changing, and it can be disassembled as needed over time with minimal disruption to the other systems. They have got open floor plates to accommodate changing tenant needs, and the technologies such as photovoltaic panels, etc., are designed, or they are designed to last for 25 years because the technology, as we know, keeps on upgrading very quickly. Talking about materials, selection of building elements on the basis of life cycle costs, and one of the most sustainable buildings is a building that lasts. So all structural materials used in the center are locally sourced from within 300 miles for steel and concrete and 600 miles for wood. With a concrete base, it has a heavy timber structure, and that too wood was sourced from responsibly managed forests, and that has lowered their carbon footprint. It also aligns with historic regional traditions and adds to the aesthetic appeal. And the steel connectors provide seismic and fire safety reinforcement, holding the wooden beams together. And as I mentioned, the living building challenge requires products to be made without toxic chemicals and procured from regional sources. So the Bullet Center demonstrates that even as the first of its kind, it is possible to push the envelope on environmental performance for a reasonable premium, while also delivering a steady stream of benefits to the owner, occupants, and society for many years to come. Today's society does not incorporate values related to public benefits into financial analysis, but that may change soon. I also have some information about cost analysis, but I haven't included as a part of this presentation here. So, optimizing the natural resources like land, materials, water, energy, as we just saw, and ecosystem. The Bullet Center has created a prototype high-performance urban office building, conceived of as a replicable model of a commercially viable structure with essentially no environmental footprint. Some examples across the world. And these are few from India. And India is an astonishingly growing economy, as we all know, and that's why the pressure on the use of natural resources is very heavy. We have rich traditions and history in holistic strategies for building and construction, as we saw in first two presentations. But despite this, the sustainable building agenda currently receives limited attention. But according to Indian Green Building Council, situation is improving and many buildings are up for certification. I'm currently designing a sustainable school in Maharashtra and few other interior and architectural projects. And I feel with more awareness, everyone will again start adapting to sustainable ways of living. Thank you. And those are few references.
Thank you. Thank you very much for your nice presentation, ma'am. And thank you for keeping the time limit also. And we've seen that the Bullet Center, which you mentioned on Seattle, yes, this case history is a wonderful case history wherein sustainable measures have been taken care of. And we have a couple of questions, and I think we'll be taking up questions at the later stage after the next presentation. So I'll now move to our next panelist. Let me put up his credentials on the screen. Yes, I now request Mr. Pinaki Dasgupta. He's an engineering, safety, environment, and sustainability professional motivated to work on climate change and sustainability through innovative processes and approach. His interests are in engineering, science, creativity, economics, and social aspects of climate change. And that's important because you've got to be socially responsible once you're talking as an engineer also. He maneuvers his energy to work with diverse cultures, communities, and organizations on the principles of 5 Ps. I request Pinaki ji to kindly share your screen and start your presentation, please. Sir, please.
Thank you, Indrajit ji. I will just take a moment to share my screen. Please let me know if it is visible. And I'll make it full screen.
Yes, sir, it is visual. Please go ahead, sir.
Oh, wonderful. Thank you so much. And thank you to all the participants who have been there for the last 1.5 hours, listening to all the wonderful speakers. And you have heard about air quality from Sandeep ji, behavioral kind of science and the aspects from Shubh, and then and kind of a beautiful case study by Rupali. And I think that makes my job a little easier, you know, because I am going to share a little bit about everything and how do we measure sustainability. So if all these good things are going on in terms of the kind of action for environmental conservation, resource optimization, so what do we have to do for actually kind of estimating the success stories? And that is one of my topic, how to do sustainability assessment. So I will just structure my presentation into 3-4 parts. The first part is to just get you an overview very quickly of the global context of why we are here and why are we motivated, what makes this time really important for all of us to join hands, to look into SDGs, as my fellow speakers have already told, to look about the circularity aspect, to look about the resource conservation. So in this decade is the United Nations Decade on Ecosystem Restoration. And if you can see, one of the focus areas is towns and cities. So that is why it is more important that we also have our projects, programs, interventions oriented towards the global goals. Now, when we talk about sustainability, when we talk about climate change, the UNEP has declared that we are currently faced with 3 planetary crises, which are climate emergency, pollution and waste, and biodiversity loss, because these are not only global, but they are also regional and local. Now, just to give you a kind of a very brief idea of what's going on in terms of the pollution we are creating, I thought it is important that we also have microplastics in mind, because now, as you all will be aware, that many items made from from plastic, steel of a certain specifications, and which we used to have called kind of single-use plastics, are now banned. So this is a kind of an overview of how the microplastics are moving throughout the oceans. And this is again, and every one of us in the panel have already told that the 5 Ps are the basis of sustainable development. If we leave one P out, then it is not called sustainable development. So in terms of construction sector also, in terms of infrastructural requirements also, we have to ensure that the 5 Ps are incorporated in every document, in every rating, in every doctrine, in every law. And when I say people, when we say peace, these are very important because of the people aspect is often overlooked as we talk about architectural needs or talk about construction sectors. But people is all about health and safety. So I think that is more important. The quality of health, as Sandeep sir also mentioned, he quite beautifully described the air pollution aspect. But there are waste, there are water, then there is the talk about energy, then talk about human rights also. So, and in COVID, we have seen that a lot of construction companies also hosted their own workforces. They gave all kind of assistance to them so that they don't have to venture out, that they are not left in any lurch. So that is a very nice example of people in the sustainable development aspect. Now, when we talk about sustainability, we also talk about the 9 planetary boundaries. These are important because these provide and kind of an, as you can see from the graphic, an ecological ceiling. And these ceilings are currently 9 in number. Most of them have been breached. Most of them are about to be breached. But here, another dimension is the social foundation, which you can see in the inner circle. So we have to, when we talk about sustainability, when we talk about sustainable development, we have to also ensure that both the ecological ceiling and the social foundations are met. The ecological ceiling should not be overshot, and the social foundations should not have a shortfall. So there are some kind of also links which you can also go and check it out yourself later on. And again, okay, so this is already discussed. I'm not going to say that because after the Millennium Development Goals, there were Sustainable Development Goals, and in the Sustainable Development Goals, we have 17 goals. But the important thing here is the 17 goals are not important. This might ruffle you, but I think the most important thing are the 169 targets. So when you go back today, please look into the targets each goal gives. For example, target 6, which is on water, says that by 2030, 50% of the wastewater should be recycled. So the SDGs are important, but the targets are more important because they give the roadmap of how do we go about till 2030. So let's quickly look out the Indian context here with the geoecology part. Of course, we have only 2% of the global land, but we have 18% of the population. That is a huge stress. And 264 districts in India are water stress at the moment. And then and you say that we are mostly an agricultural fed country, so that makes all the more important. And when we come to some statistics, some data on natural resources, this is a very real eye-opener as we see that India has more annual freshwater withdrawals even compared to China, the United States, and other countries. So this is the BRICS kind of comparison. When we talk about the environmental, you can say constitutional aspect, we see that it is well covered. Article 21, Article 51A, 48A. These are all very important because that's how we get motivated. That's how every builder, every engineer, every architect has to have a consideration on all these aspects to truly make a project or a program really sustainable. These are some of the environmental rules. I'm not going to kind of deliberate on each of them, but these are also the rules which we have to maintain when we do construction project or infrastructure projects. For example, highways, bridges, large construction, housing projects, all these type of things. So also India is a signatory to different kind of international conventions, which also guarantees the protection of natural habitats. Also, we have right now EIA notification 2006, which has been modified in 2014, and there are a lot of other laws which kind of give our direction on how do we make our project ecologically sustainable. But when we talk about sustainability, and I would come next to it, is not just about ecology. It is about also it is all about emerging aspects. So what we know about sustainability is this: like when in sustainability is something which started in 1713. It was started in Germany by a guy called Hans Carl von Calvus. He was from mining department, and he said, if we kind of continue cutting trees at a rate which the trees can't grow, then there will be a problem in the future. So it all started there. Sustainability is not just three decades old. It is about couple of centuries old that way. So here we have seen three major pillars of sustainability. But now, as we talk, researchers around the world, UN organization, they are adding more pillars. So it is not just the environment, economics, and social, but it is also the cultural aspect, the ethics aspect, the technological aspect, and the institutional sustainability. Because if we don't have the institutional, if a company does not have institutional sustainability, then any action taken by that company and it is considered or assumed would not be in total kind of resonance with the global goals. So let us have some kind of idea, and these are being touched by my fellow speakers already. But what I could say here that we follow CCB, which is what is CCB? It is the opportunity for caring, loving, and appreciating natural resources. So whether it is through biomimicry, whether it is through nature-based service design, we have to be conscious of all these things. So my kind of offering to this today's training is a conscious design, compassionate design, and a bold design, because all these three are very important. Why bold? Because normally what will happen is the cost economics won't settle down, or you might have to go an extra mile convincing your client of doing or getting something which is sustainable but which might not click with the project proponent. So that's why we have to be bold. That's why we have to be compassionate, which is really empathy towards fellow human beings and fellow nature, to see that, and that's why sustainability has it's all sometimes called triple bottom line, as mentioned by Shobh. So what are the optimization potential? And this has also been touched by Rupali. She has nicely mentioned about a case study which has done a lot of these things. But here I just wanted to repeat that, okay, when we say optimization potential, what is that? So when we can look into several kind of pillars. Those pillars are waste management, of course, and waste management is not just solid waste management. It is about waste management for materials, for your own project, and these are things which we can do at the design phase. That is the best phase where we can plan something at least, and then the implementation comes. But for the planning stage, it is very critical to explore the kind of state-of-the-art technology. So I have written waste to energy. Why only waste treatment or management? Why don't we convert waste to energy? Because there are a lot of technology options available now. And we have to have the will. That is why Shubh's presentation is also important, that the psychology has to be like this, not only for the clients, but also for us, for engineers, architects, for MEP consultants. We have to have our own kind of psychological orientation, and we have to kind of move the big rock. We have to move the barrier. So just to give you kind of a glance of the environmental footprint, which has been also touched by in this Deep G. So when we say about the emissions, we contribute to 37 to 39. Data varies. Data varies because some say 37%, some scholars, some says 39%. And then we have 40% of the global energy consumption. This is the data I took from the IEA website. And there are some resources which are given to the Institute of Engineers to be shared with the participants. So these are already there. But the interesting part here is the savings. So the savings, if we do sustainable design, it comes to 3,000 megatons of carbon dioxide. That's quite a lot by 2040. And then for material efficiency, we have 50% cost savings, and the business opportunity through sustainable design, optimization of natural resources, and sustainable planning comes out to be 17.8 trillion US dollars. So this is the kind of figure we are looking at, the magnitude we are looking at. And coming on to some of the orientation of global houses or global organization, there is a alliance called Global Alliance for Building Construction, Global ABC. It's a UNEP-backed organization which supports life cycle assessment as science-based target. The Green Building Vision says that, and they have revised it. If you go to their website, you can see that in the vision, they state that they want to have 40% less embodied carbon emissions by 2030 and 100% net zero emission by 2050. India has its net zero emission by 2070. That is understandable because we are an emerging economy. We also need some share of our historical carbon. So I think it is, but always there is a scope, and then the IEA declares that whenever we kind of, the word they say is decarbonizing buildings. That's a new phrase. So decarbonization buildings means that the entire life cycle, and you have seen in the example of the Bullet Center that they have taken, I think, some consideration of the life cycle of the building. So how do you do this kind of sustainability assessment? And this is the last part of my presentation, is you can do, there are a lot of tools where sustainability assessment can be done, through which sustainability assessment can be done. But one of the tools which I would love to touch right now is the life cycle assessment. A life cycle assessment does not necessarily mean only environmental life cycle assessment. It means life cycle costing and social life cycle analysis. These have been added. Life cycle assessment was actually framed 3.5 decades back by the Society of Toxicology and Chemistry, and then it was also revised by UNEP and other agencies. I'm not going into those kind of thing, but just to give you an idea of how LCA works is basically we have three inputs actually. They are called inputs to Technosphere, and we have to have the bill of quantities for construction phase, for operational phase, and demolition phase. So for example, in construction, we normally don't take demolition, but we take the entire life cycle into account of a building and the materials, and then the energy flows. And then normally we have the outputs in terms of the emissions. Now, life cycle assessment is not just about carbon dioxide or GHG emission. It provides impact categories, which are called midpoint impact categories. And when you do an analysis, it's called midpoint analysis. And then when we do the final output, it is called endpoint analysis. So there are different softwares available. CIMA Pro is there, Gabi is there, then a lot of other softwares are there. But the entire fundamental of LCA hinges in terms of the total embodied emission and energy and wastage right from the construction phase to the demolition phase. So that is how the LCA works. And in terms of executing the LCA, we have two standards by ISO, 14040 and 14044. They are basically having four steps. I have added another step called extensions. The four steps are goal, inventory, impact, and interpretation. Very quickly, goal is what is the purpose of LCA. So are you kind of going for a green certification? So normally in the EU and the US, before somebody goes for green certification, normally they also carry out a building LCA, because that gives a science-based target. That gives you an engineering kind of indicators, so that you designers, planners, architects, you can work towards the optimization of resources. It is not because, for example, if you are using bamboo, one might say it is a sustainable construction material. But if the bamboo itself is being flown from 2000 kilometers, then there has to be some kind of question. So LCA gives you those kind of decision-based kind of figures, indicators, where you can actually put a more viable designing project. So in the inventory analysis, we have raw material consideration, water, waste, finished product, even transportation. As I said, material transportation is also important, and the energy, both embodied and as well as from the usage of energy during the occupation phase. So as I've told that it is also a midpoint. There are different kind of analysis, midpoint analysis, endpoint analysis. What are these? These are not to be confused. Very simply, midpoint analysis are the different indicators which you will get from conducting an LCA on how your project is impacting the environment, and you are getting some values. It is not a qualitative measurement, it is quantitative. So you get a value in terms of some units. And what is endpoint? Endpoint is an extension of midpoint, wherein you get a common value and you get a more focused characterization of fossil fuel usage, resource depletion. So that is why it is very important that if a full regular LCA is conducted, it should actually culminate into midpoint. So these are graphical representation of what I've been talking. So if we have these kind of inventory list, and it might seem that they are very complex in terms of the raw materials or the inventory list, but we can readily measure them. For example, if you measure air pollution, we will get the values of SOx, NOx, PM 2.5, PM 10, ozone, and if we take the water, wastewater into consideration, we will have BOD, COD, total nitrogen, phosphorus, and these are the things which kind of make up the inventory list. Also, the material of construction. So what amount of steel, what amount of wood, what amount of glass, what amount of concrete, what amount of cement, what amount of paint we are using. So all these are come in the inventory list. And when we extend that to a treatment where I have already told the midpoint analysis, we get these 18 parameters. Now, different methodologies give different midpoint parameters. So there is a methodology called recipe, there is a methodology called CML, there is a methodology suggested by SETAC, there's a methodology by UNEP. Some methodologies are only for European Union, some methodologies are only for US. There are no methodologies which have been developed for Indian condition right now, but we normally use the global acceptable methodology, which is called recipe, RICEPE, recipe. And when we talk about the endpoint, we have 3 indicators, which are human health, ecosystem, and resource availability. So these are important when we talk about LCA and we talk about the interpretation. So these are all extensions. And from the midpoint to weighing, what is weighing? Weighing is nothing but dividing your LCA values by a standard value. For example, we calculate air quality index, the similar way we also carry out the weighing and other things. So these are, I thought I'll give them some example. Of course, this might be a little heavy for you, but very simply, as you say, that if we take climate change into account, so climate change is not only about carbon dioxide. Right now, we are very focused about carbon dioxide emission. Everybody talks about carbon. Everybody talks about carbon. But the essence here is to extend that to methane and CFCs and nitrous oxide. So how they fare in terms of climate change, then ozone layer diffusion. And this is how the results are popped up when you do the LCA treatment. So this is basically a kind of example from my own research of wastewater analysis. So we see that even when we say that we have wastewater as a sustainability measurement, but within that wastewater treatment, if you use a lot of paints, if you use a lot of material which are from far away, if you use polymeric membranes, then probably, very strictly speaking, that might not be sustainable as compared to very rudimentary or kind of a biomimicry based approach or kind of a approach where we use plants or kind of algae or kind of other materials for wastewater treatment. But these are all decision making kind of things. And this is again, I think these examples have already been by Rupali. These have been already given by Rupali. So I just thought I'll just pop it up. I haven't included the Vancouver Convention Center. But the vertical gardens, the metro pillars, they are amazing. I think they are aesthetically nice. They provide a green touch and they work. So, and then if we go to the city level, we have Bengaluru and Malmo in Sweden. They are considered as one of the sustainable things. Of course, Bangalore's traffic is a little kind of subject of discussion, but I think that's a nice city. So I just conclude by giving you some kind of the track examples of creativity using waste material. This is by Joanna Burke in New York. These were created by dried greens, beads, and seeds. Then this is one of my friend Yasser from Comoros. He used tires to grow the plants. Even in India, many people are doing that. And there is, you see, a waste bin made up of used tires and a kind of a sitting seat made by used tires. This is again by a kind of an artwork in Lodi Art Colony by my friend Archana. And this is again a kind of creativity where we designers, architects could use for communicating all about SDGs, all about ecology in our own building, in our own way. This is one of the public projects, but we can also have collaboration and all the buildings. So these are some of the references. I have used. And thank you so much. It was a pleasure sharing my thoughts with you. Thank you to all the organizers.
Thank you, Pinaki, for your extensive presentation. And definitely, it needs more time for you because working on the building life cycle assessment is very important, and it is a need of the hour because once you are designing a building and you are doing sustainability or measures in the building, you need to analyze what effects we are getting through it. So that's more important. I'll quickly move to question answer session. We are very short of time. I think we've overshot the time. I'll just take two questions which are very pertinent. First question is for Mr. Narang. This is from Srijesh Sivan. He says that are there any regulations existing for display of signages relating to conservation of resources and sustainable solutions? So he's talking about the signages. Are there any regulations for that or not?
No, sir, there are no regulations for signages, but these signages are meant to convey the messages on, usually we see the signages on safety and security at the project sites, but we don't see any signages on sustainability or sustainable constructions at the project site. We should be showcasing these signages. And Swachh Bharat Mission is one of the biggest examples of how showcasing or how creating a public opinion on being clean, being gone through the signages or putting it in the observation of the people.
Yes, I think that's very important because signages play a very important role in educating the people, and I think the vernacular signages are most important because, as you mentioned, for L&T example, they got 5 lakh fine just because I think the lowest level people were not informed of the things they had to do. So that has to percolate downwards. Thank you, sir. I have one question for Rupali ji. The question is that I believe you were working on some mitigation strategies for UHI effect in Pune. So yes. Can you give us couple of examples or strategies which you would like to present so that people out here in NCR can use them?
Yes, so I am looking at, first of all, the reflective paint, which works very well. And I'm also researching on urban farming. So the project I'm working on currently for the office building, we are going to have some urban farming on the terraces so that there's lesser penetration of heat, and that's how we are trying to that's how I am looking at it, or myself I'm working on that. So these are two things which I'm doing working on right now.
So have you made any modules for dissemination to the normal people, normal educating people, or maybe down the line?
Yes, I have been working on how to integrate climate change into the syllabus of students, actually, not as a separate topic, but whatever they are learning. For example, even if economics or poetry or physics or chemistry. So how to integrate climate change and their effects really in the syllabus is what I was working on. Right now it's slightly on hold, but yeah, okay. That's what I'm...
Okay, I think that's a very good measure. I have a small question for Pinaki. You've actually extensively talked about building life cycle assessment, but is there any code in India wherein people can actually go for this assessment system or this? Is there any provision or some codes or anything in India?
Sir, actually, in IIT Delhi, we have one course which for life cycle analysis, but we will also be happy to explore any kind of collaboration with ASSOCHAM and Institute of Engineers, because it's also a premium institute. We can kind of formulate such kind of courses for other people. I would be very happy to do that.
Yes, because that's more important, because after you design the building, you need to actually check.
Yeah.
Because as Narang said that yes, building designing is one part, building execution is one part, but what about 5 years down the line, how the building is behaving? That has to be, assessment has to be done. So
Yes.
I think, thank you very much for all the valued our presenters, and really it has been a wonderful experience, and listening to you, all the panelists in your field, you are all very have extensive knowledge, and we've got a couple of congratulation messages from very many our attendees. Mr. Gopalakrishnan from Hyderabad and says that excellent presentation by all the faculty and IEI, and congratulations and thanks. Thank you very much, sir. So I'll just wrap up the session now. I request our Honorary Secretary Kuldeep Gupta ji to kindly say a vote of thanks so that we can wrap up the session. We are already overhead of time. And I request all the attendees, if you have any more questions, kindly send us to our email. We'll forward it to the panelists. Sir, please.
Good evening, everyone. Respected President Sir Dr. H.O. Thackeray, Chairman Engineer Sandeep Handa, IEI Frida Local Center, our distinguished speakers, my fellow FLCC committee members, and all audience present. On behalf of the Institution of Engineers, Frida the Local Center, I take this opportunity to propose vote of thanks to those who have directly or indirectly contributed to this webinar on optimization of natural resources and design towards sustainable construction in civil engineering. I would like to express my sincere gratitude to Mr. Sudeep Chakravarti, Assistant Director Technical, and their team for their support for this webinar to happen. My sincere thanks to Sudeep ji. My sincere thanks to very learned and eminent speakers, Mr. Sandeep Narang, Mr. Subrat Raj, Madam Rupali Gadekar, Mr. Pinaki Das Gupta for making excellent presentation and making this webinar educative and very meaningful. I extend a really hearty vote of thanks to our President Dr. H.O. Thackeray, who has spared time from his busiest schedule to grace this occasion. We are really entitled with your knowledge and presence, sir. My special thanks to the event moderator, Engineer ISI, as ever, for the entrenching support and making this event a great success. But last but not the least, I thank to our honorable IA members and all the participants who blessed their presence and took the valuable time from their busy schedule. Your presence and participation made this presentation, made this event very up to the mark. With these warm words and a kind message, we move to the end of the today's webinar. Thank you very much. Thank you. Jai Hind. Dhanyavad. Thank you.
Thank you very much.
Thank you very much.
Thank you, sir. Thank you very much. And with your permission, I now close the session. Thank you very much from the bottom of heart to all the panelists, to all the attendees. Thank you very much for making this event a success. Thank you. Jai Hind.
Jai.
Jai
Thank
Hind.
you.
Thank you, sir. With the permission of the chair, I am ending the webinar.
Okay. Thank you. Thank you, Sudeep ji. Thank you very much.
Thank you, sir.
Thank you, sir.